Thank you very much for attending this talk, and I hope everyone here brought your tinfoil hat for this talk. Did you ever wonder why organizations, companies, or even the governments try to de-anonymize you and navigate on the internet, and how they are still able to do that even when you disable cookies in your browser, in your default browser, for example. So in this talk, we'll try to cover a little bit about the whole history of the fingerprints on the web environments, in the browsers, and towards the end, we are going to talk a little bit about more like more advanced fingerprint techniques, and also like how Tor tries to mitigate that. By the way, I said try because security is basically a cat-mouse game, and attackers are in a constant pursuit to circumvent our fingerprinting protections. So it's a no-end game, and normally the user always lose. And the final thing I'm going to say before going to start talking is I'm going to say the word attacker a lot. So when I say the word attacker, we can think about anyone who tries to de-anonymize us, like could be a company, a tracker, advertiser, and things like that. So that's it. So like I said before, I work for the Tor Browser, mainly work on the mobile stuff. I work a little bit with the fingerprinting proxy bypass. So if you have any question about Tor Browser, any complaint, feel free to stop by and ask anything about Tor. So before talk about track, we need to understand what is the motivation. Like in the security world, it's common before talking about defense and attacks, we need to think about the attacker's mentality. So we need to know why people want to attack the user, want to de-anonymize the user. So as Tor developers, we have a design document, and we think those are the mainly kind of goals of the attackers. The first one is analytics. So people want to know, organizations want to know what the user is doing, how many times a unique user accessed the website. So it is why people normally do analytics, target ads, personalization. So sometimes a company wants to have wants to send the user a handcrafted experience. So it is, and by the way, not all are evil. Some things make sense, but we really believe in like lawful consent. Fraud detection and then de-anonymization. The de-anonymization probably is the most evil of them because they normally are made by dictatorships trying to de-anonymize dissents. So these are the main goals of attackers. But before talking about fingerprint techniques, we need to understand why the fingerprint techniques are more and more advanced these days. And one of the motivations is because of the cookies. So I love this, this quote from LA Times, from an article from the 1996, where it says, cookies are nuggets of data that can be stored in your PC by a website and then accessed every time you go back to that website. And the interesting thing about this quote is because they says that sites, the concept of third party was not that clear at that time. So again, it was self-contained to a single party, to a single site. And the idea of cookies are really simple. Probably everyone knows here how cookies works. And so the first step, the user browser requests a web page. The server sends back the page and the cookies using the setCookie header. And finally, when the user is accessing a page from the same website, so the server knows the user already visited that page. Simple, it's easy. But what happened after the cookie was created was people were able to attack users. They were able to track users, especially like advertisers and trackers. And they did that because cookies are really easy to reason about. Anyone can understand how cookies works, and anyone can play around with cookies. So in 1996, third-party cookies were being used everywhere. So in 1996, DoubleClick was also created, so it was launched as a company, one of the biggest trackers advertising the world, bought by Google, by the way. And how third-party cookies works is almost the same. The main difference is now in your page, you have an advertiser there, normally embedded in an iframe. So the iframe lives in another party, in another domain. The user sends a request to fetch all the content from the website. The advertiser and the content website, the server sends the content plus the advertiser, and the advertiser also sets a hook. But when you go to another website, the advertiser reads that hook, and they know what kind of thing, what kind of site did you visit before. So in this good example created by Guns on his PhD thesis called Online Track Technologies and Web Privacy, it explains, for example, sometimes you're accessing a news website, and later on you can access a health website searching for Alzheimer, cancer, or something like that, and now the advertiser knows what you are doing. So the concept of third-party hook is in our lives today. But few people felt not so happy about that. Like, for example, the ad blockers, and they start to create a bunch of ad blockers. We have Privacy Badge, you have Panopticlick from EFF, AdBlock, Ghostry. So a bunch of ad blockers try to prevent third-party cookies. However, what happened was preventing cookies is not enough anymore. You need to change how the browser behaves to have real privacy these days, because JavaScript, CSS, the HTTP headers, how the HTTP protocol behaves, everything like expose the user locality, besides the user locality, it's expose the user's machine, what kind of machine I am, it's expose what language the user navigates on internet. So all tools are amazing, but they are not enough right now. They are like, if you want real privacy, they are not enough. So let's talk a little bit about browser fingerprints. The Tor browser have, like I said before, we have a document, a design documentation, where we talk about what kind of fingerprint attacks trackers, advertisers, governments tries on users, and the main four of them are request behavior, JavaScript attackers, CSS attackers, and plugins. We're not going to talk about plugins because if you are using a plugin, you are already screwed, sorry. So the first one, the most simple one, is the request behavior attack. And basically, it is when you are requesting content from a server, and it's mainly about the accept headers and user agents. There are others, but the others are more in the HTTP level, HTTP connection level. People are able to de-anonymize you based on the HTTP specification, but these one are the most simple one. So a good example is accept language. So a tracker or advertiser knows you are English speaker if you send the accept language English US, or accept encoding. So the accept encoding is interesting because every browser has a different accept encoding, and so trackers or malware people, malware attackers, they know what browser you are and can provide you malware specific executables for you. And the user agent, this user agent in fact from the Tor. So every time you access websites, the website thinks you are a Windows machine. So it is why there is Windows NT. So it's from the past, and we never change that. The other one is now thinking more about JavaScript. JavaScript is really interesting because it's an amazing language. It allows you to do anything and everything. And in the security side, when you do everything and anything, it's terrible. So I don't know if you ever use a Tor browser, and in the Tor browser, there's one thing called security slide, one component called security slide, and you can change how much safe you want. For example, the default option, JavaScript enable, you are able to play video, you are able to play audio, but when you move up a little bit to the safe, to a more safer privacy, we start to disable things from the browser. We start to disable JavaScript, we start to disable video, we start to disable audio, and I'm going to explain a little bit why. So the first thing is the navigator object, the window.navigator object. This object exposes so many things. Like, for example, in this example, they expose my language, even they expose what platform am I. So when I took this screenshot, I took from my MacBook, so it says in the platform, Mac Intel. So attacker is able to know I am in a MacBook, and it's scary, really scary, especially like if you are, I don't know, in Iran, or like Turkey these days is also crazy, so it's really scary. JS exposes that much information. Other one is other JS object who expose our information is the screen one. So the problem about the screen is because when you are on mobile or when you are on notebook, when you are mobile, especially Android has so many screen dimensions, sometimes you are able to know what's the specific device based on the screen. So on this example, we are showing like the whole screen for same MacBook, and also the pixel depth is also really scary. You should never expose that. So we try to mitigate that, like make the values uniform. There is two kinds of mitigations. A lot of researchers explain the papers. The first one is make everything uniform. All the users should have the same values. So it's the approach you use on Tor Browser. And the other one is add some noise. Each user is going to have a different value. We don't do that because it's a little bit hard to do that, to do that without adding issues to the browser, because every time you access something, it's going to need to add a noise, and we can make an issue. So we make like locales, dates, vendors. We try to make everything uniform. So, for example, dates. If you are using a Tor browser and you instantiate a data object and see what's the current date of the user, you are going to see all of them are in the UTC-0. All of them are in the Greenwich. So we try to normalize everything. When you show the vendor, all the vendors are the same. We try to bundle the language inside the browser. So to normalize everything, all the fonts, we bundle all the fonts together with the browser to make it the same across everyone. So we try to make everything uniform. So the second one is the web audio. The web audio is amazing. It's an amazing API. I remember when it was released, and the gamer developers, they were insanely amazed about that because they were able to do a bunch of stuff. However, since 2016, 2015, few researchers start to notice audio being played in few websites. However, not being played the user is able to hear the audio, but being played in the background. And they noticed web audio was being used to track users, but why? The first thing is the audio context. So every time you create a web audio object, you must create, every time you're going to use web audio, you must create an audio context. The audio context exposes so many information about your machine, and some of them are unique. Even if you have two MacBooks from the same year, but in the same day, they are unique. For example, the base latency is totally different from machine to machine. The current time is also different from machine to machine. What is not unique is the destination. Sometimes they have two, the numbers the same, and other things are the same across machines. But one single object can expose so many information about the user. So we try to normalize a little bit as well. And there is and this one is the most scary one. So basically this graph is when I play one single audio, but the user is not able to hear. I just create audio context and play that. So the bluish line is a baseline created by the experiment, and the red line, it's red curve, it's my machine. So one machine is different from the machine. Doesn't matter if it was bought in the same day, bought in the same place, was released, has the same configuration. Each machine is different from other machine. So when you play this audio, you can see difference between them. So this block here, this visualization was created using these codes. This code was, in the previous slide, there is a paper, and this block of code was taken for that paper, and the code is really, really simple. It's basically create analyzer, create oscillator, and playing that. Like, after that, you just get the data, get the frequency, and the frequency is different for each user. So, and even worse, not just each browser, but each browser version is different. So if I play this code in Firefox, I don't know, 59 and Firefox 60, they are totally different values. So, like, web audio is insanely crazy to fix all the issues from the web audio. So we decided to disable it. Like, it was almost impossible to make it uniform without breaking the whole user experience. And now, probably is the most interesting of them, because it's so simple to explore and so many people explore that, is the time-based side channels. One thing about JavaScript is, like I said before, the CPU, you can get the same CPU, the same chip, it was being made in the same day, they're going to have few difference. So JavaScript is really complex. JavaScript has a just-in-time, the memory management, each engine is different. And JavaScript runs on top of the CPU because of the JavaScript just-in-time. Based on that, we are able to know how long a function takes to run and fingerprint that. So a good example of that is all those functions here. We are able to calculate the difference between when a function runs and use those functions to calculate that. So a good example is this block of code. It's really, 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 really simple. It's basically, so it was written by Andrew Bortz in 2007, so it's not something new. Like, time-based side channels are known for like years and years. And this example, basically, they want to know how long the network stack in the browser errors out when the image source is not an image. For example, in the line 9, if you look at the line 9, the test.source is not an image. So with this code, we know how long the browser, like the JavaScript sends this URL to the network stack does a lot of computations and fails out, saying, okay, this is not an image. So like, it's a really simple code, and we can do kind of things to try to prevent this kind of attack. And the thing we do, we try to remove granularity. We clamp the difference between timers, we clamp to 100 milliseconds. So if you get the performance.now and subtract by other performance.now, the minimum value will be 100 milliseconds. It's the best we can do because everyone agrees side channels, time-based side channels are terrible, and ideally we should remove any timer from JavaScript. However, it's not possible. It would break the whole web. So this is one alternative we do. We try to clamp the value, and it works reasonable, but again, it's not a silver bullet. Like, we know someone can explore that. People, like bad intentioned people, are able to explore that, like even increase a little bit more the timer. But like for the majority of the attackers, it works. The other thing is the canvas 2D. The canvas 2D is also like really interesting because each browser has a different graphics library, and each graphics library, even for different operating system, renders differently. So the canvas 2D attack basically renders a bunch of things on the screen using the fill text, fill style, fill rect, and use the toData URL to get that data, to get that image and send to a server. Like, and so this image is basically a key in a hash map. So we tried different approaches to try to mitigate that, but sadly we moved its complexity to the user. So in this example, I try to access the HTML5 canvas tutorial, and it shows a pop-up on my screen saying, okay, this user is trying to extract HTML canvas image from your browser, and you cannot not allow, you can allow. So we move its context to the user. It was the best thing we could do. About that, like that attack. I think Mozilla is experimenting a little bit. Like Mozilla is also using the same idea. They are experimenting a little bit, but right now they are kind of following the same idea as well. Now talking a little bit about CSS. One interesting property that trackers are able to fingerprint the line height. So line height is basically the ascender, the descender, and the font size. So, but for different machines, those values are different, especially on Firefox. So on Firefox, if you get the line height if you get the default line height, so for Linux is 19 pixels, for macOS is 19.51 pixels, and for Windows sometimes it's 19.2 or 20. So, but why it's happening? It's because fonts are broken. Fonts are terrible, and it's really hard to create a font. It's really hard to create a font, and each machine, each browser, each operating system has a different default fonts, and each font has a lot of issues. So it is why on Firefox, when it uses the font from the system, the font from operating system, the line height is different. So we also try to uniform that. So instead of the default value being the ascender plus the descender plus the font size, we multiply by 1.2. It's what W3C recommends, so we are following the specification at least. But again, it's not amazing. Ideally, it should be fixed in the font size instead of in the font's platform side instead of browser side. And talking a little bit more about CSS, we have the media queries. Media queries are also able to track you, like the properties. We have like the device aspect ratio, device height, device width, are able to track the device, the user's machine size, device size. So what we do, we also uniform those values. So the default aspect ratio we put is the 1.0. We create for the width and height, we also make them uniform. So if someone tries to know what's the size of your device, like when say size, screen size of your device, we lie to the requester. So, and the last thing is, I didn't talk about it, was we do also something about cookies, and Mozilla called that first-party isolation, what we do, and we are a little bit more fancy. We call cross-origin identify unlinkability trademark. And basically it isolates all the identifier source by URL. What are the identifier source? Cookies, shared workers, blob, storage. So for example, when you are accessing a website and this website has ads inside the iframe, we isolate this ad just inside that iframe. All the cookies, all the shared workers, all the blobs, all the storage, Canvas, WebGL, will like try to isolate everything based on the URL. So the URL is a key to any identified source. It looks simple, however, it breaks the whole web when you enable that. So it is why Mozilla doesn't enable by default, because when you enable first-party isolation, a lot of browsers, a lot of front-end programmers, they want to be able to communicate across the whole domain. And with first-party isolation, we don't allow that anymore. Thank you, guys.